Hello guys, welcome back to another video of science. Today we'll be looking at energy changes, which is a topic of chemistry GCSE. So today we'll be looking at exo and endothermic reactions, the law of the conservation of energy, a required practical, bond energies, reaction profiles, and chemical and fuel cells. Plus we'll be looking at evaluating the uses of chemical fuel cells and rechargeable batteries, etc. Endo and exothermic reactions. When a chemical reaction happens, energy is transferred to or from the surroundings. So when it's transferred to the surrounding, it's called an exothermic reaction. And so the temperature of the surrounding increases. Examples of this are oxidation, neutralization, combustion reactions. When energy is taken in from the surroundings and the temperature of the surrounding decreases, this is called an endothermic reaction. Examples of this are thermal decomposition and the reaction between citric acid and sodium hydrogen carbonate, which is sherbet. Other applicational uses of exothermic reactions are oxidation, hand warmers, which are quite common in the UK because of the chilly climate, and also self-heating cans. The law of the conservation of energy. The law of the conservation of energy states that energy cannot be created or destroyed, just transferred. So during chemical and reactions, energy used to break chemical bonds between the atoms in the reactants is the same as energy needed when new bonds are formed to make the products. If the overall energy is released to the surroundings, the reaction is exothermic, and if it's absorbed from the surroundings, it's endothermic. Required practical. So required practical is to investigate the variables that affect temperature changes in reacting solutions. The apparatus needed for these reactions are polystyrene cup, thermometer, 250 cm3 glass beaker, measuring cylinder, top pan balance, and two reactants, usually an acid and an alkali. Method. So first we have to add one of the reactants to the polystyrene cup. So a diagram on the above shows polystyrene cup and the other apparatus required. So add one of the reactants to the polystyrene cup, measure and record the temperature with the thermometer. So this could either be the acid or the alkali. And then add the second reactant, record the temperature every 30 seconds. And record the minimum and maximum temperature. Step 3 is calculate the temperature change from the results. And step 4 is to make it a fair test, repeat, discard anomalies, and calculate the mean. So an important aspect of every required practical is also finding the IV, independent variable, dependent variable, and the control variables. And also making it a fair test is quite important for most practicals. Reaction profile. A reaction profile shows whether a reaction is exothermic or endothermic. It shows the energy in the reactants and the products and the difference in energy between them. So for an exothermic reaction, the reaction profile, there's a decrease in the energy released. The reaction profile decreases because energy is given out to the surroundings, which makes the surroundings warmer. So there's the amount of activation energy and energy release are equal, and it's a downward diagram, as we can see on the first image. So as the reaction progresses, it goes down. On the other hand, for an endothermic reaction, the activation energy is greater than the energy absorbed. And as we move along, the reaction profile increases as energy is taken in from the surroundings. Bond energies. During a chemical reaction, energy must be applied to break bonds in the reactants. Endothermic. These have positive energy change values as energy has entered the reaction, as opposed to exothermic reactions, which have a negative energy change value as energy has exited the reaction. Energy change is break minus make. So the energy change is the amount of energy needed to break the product and subtract the energy needed to make the new product. Chemical cells. Chemical cells use chemical reactions to transfer energy by electricity. The voltage of a cell depends upon a number of factors, including what electrodes are made from and substance uses electrolyte. So this can be decided by looking at the reactivity series. A cell can be made by connecting two different cells with an electrolyte. In non-rechargeable cells, the voltage is produced until the reactions are used up. On the other hand, in rechargeable cells, the reaction can be reversed when it's charged. The reactivity series can be helpful. So we don't need to by heart this or know this for the test. We just have to have a rough idea uh, about the main elements in it, like hydrogen, copper, hydrogen, carbon, and maybe magnesium, aluminium are quite important as well. Fuel cells. Fuel cells constantly run as long as they're supplied with fuel and a constant supply of oxygen. The reaction takes place at a lower temperature than if it was to be burnt. Energy is released as electrical energy, not thermal energy, which is what happens when chemical cells react. Hydrogen oxygen fuel cells are an alternative to rechargeable cells and batteries. In a hydrogen oxygen fuel cells, hydrogen and oxygen are used to produce a voltage. Water is the only product. At the negative electrode, it's 2H2 plus 4OH minus goes to 4H2O plus 4E minus. At the positive electrode, it's O2 plus 2H2O plus 4E minus goes to 4OH minus. When you add these two half equations together, you get 4H2O plus 4E minus plus 4OH minus. The hydroxide ions, electrons, and two hydrogen molecules will cancel out because they're on both sides, leaving the overall equation as 2H2 plus O2 is 2H2O. Finally, we'll be looking at evaluating the use of fuel cells. So we'll be looking at alkaline cells. So the pros of this are they're cheap to manufacture. Cons are that it might end up in landfill sites once fully discharged, and so it's waste. And recyclable, though it's expensive and it's not good for the environment as well. Rechargeable cells can be recharged many times before being recycled, reducing the use of resources, but they still will be in landfill site at some point. And the cons are that costs a lot to manufacture. Hydrogen fuel cells, easy to maintain as there are no moving parts, small size, water is the only chemical product so it doesn't harm the environment. But the bad thing is they're very expensive to manufacture, need a constant supply of hydrogen fuel, which is a flammable gas and can cause fires. Thank you for watching. Please like, subscribe, and look out for my other videos.